Right, now we're going to be looking at how do we measure direction. In the previous video we saw a little bit about this when the runner was running around the track. And so when we talk about displacement, remember it is a vector quantity and we have to relate that to the magnitude but also a direction. But there's different methods of saying a direction: left, right, up, down, north, south, southeast, and then we can have like bearings, so 23 degrees. We can have a different type of bearing known as a compass bearing, so we can go north 23 degrees east. So let's talk about that, how we can describe the direction of an object so that we can have a full description of the vector, the magnitude plus the direction. So in terms of our syllabus here, it says we're going to be looking at the graphical interpretation of data. So we're going to be drawing arrows to show the direction in which objects travel. And so we're going to be graphically doing that with our vector representation. But we're also going to be looking at how do we do that in terms of an algebraic description. So we're going to be using quantitative data to calculate the actual magnitude. But when we do our vector diagrams, we're going to be talking about how we can do that in relation to the position and bearings. Alright, so let's say we have this situation here. We've got a tractor and this tractor is driving on the farm. Okay, and so we can see from this particular diagram we've got different viewpoints. We've got a viewpoint along the x-axis here, so we're driving this way and then they can reverse that way. So we're going backwards and forwards along one dimension. Remember 1D motion, the train in a straight line. Then he could turn left or right and he can go north or south. And so on this plane or slice through the earth that is focusing on the horizontal direction, he's traveling horizontally, left, right, up, down. And so we have 2D motion there, but it's on that one plane. And so we can break that 2D motion up into a north component, a south component, a west and an east component. He's not traveling vertically or he's going downwards. If he did, he'll be traveling in a third direction, and that's sometimes known as the y direction. So if I was to say x, and that's y, then this one going up would be z. Okay, so he's got 3 dimensions there. So he's traveling 2 dimensions on the horizontal plane. Okay, so let's have a look at how we would describe that. So we have our tractor going along here, and we can see that our tractor is traveling on this first dimension here, the west-east dimension. Okay, he's not moving up in the y or the negative y down there, or the positive y, so north or south. He's not moving there at the moment. He's just going backwards and forwards. So we have simple 2D motion on the horizontal plane. But what about if he starts turning away from those coordinate points? Let's say he goes up this way. So how do we describe that? Well, the first method of describing it is with true bearings. Now, true bearings is when you start from north and you move clockwise and you use 3 digits. And those 3 digits are bearings, and you put a capital T behind that saying it's true bearings. So for this one here, we're going from Z there to where he's traveling at. That's 35 degrees, so you would label that as 035 degrees with a capital T. And so that's 35 true bearing. If he was to drive down this way, then if we start again from north, we work our way around, and we go to where he's moving, and that is 193 true. Okay, so true bearings start from north, they go clockwise, and you know that that is 90 degrees, a straight line is 180 degrees, and then 180 plus 90 gives you 270 degrees, and then you end up with back to 360. So that is true bearings. What about another way of measuring it? Well, we have this thing called quadrant. What about another way of measuring it? Well, we have something called quadrant bearings. Now, with quadrant bearings, we reference to north or south. Okay, so let's have a look here. Our tractor was going in 35 degrees before, so that was 35T. In quadrant bearings, what we do is we start from north, the closest north or south pole, we start from there, or east or west. In this case, it's closest to north, right? So we start from north and we work this way, and we go, okay, that's 35 degrees towards the east. And so we label that as N for north, 35 degrees towards the east. That's how we do that one. What about our one that we had before? Well, we're going down this direction here. This is closest to the South Pole, so we start from south and we say it's 13 degrees towards the west. Okay, and so that is how you label that one. South, 13 degrees towards the west. So this is quadrant bearings. But then there's another plane there, isn't there? So far we've been talking about the horizontal plane. There's also the vertical plane, going upwards into the air or down into the ground. And so if you were to fire something, let's say like here, this tractor was to fire, I don't know, it was to fire a firework, for example, up in the air, it could go up like this, up into the air now. And so it's going up in the vertical Y direction. And it's also traveling a certain distance in the X direction on the horizontal plane. So it's actually now got two components in the vertical direction. Okay, and it's traveling at an angle at 40 degrees. Okay, and so we have our 2D motion again, but this time it's in the vertical plane. So just be wary that when we talk about motion, it can be motion on the horizontal plane. So it could be simple rectilinear motion just in the X direction, going backwards and forwards on a horizontal plane. It could be going at an angle on the horizontal plane, so it's got north, south, east, west in it, for example. So that's 2D motion on a horizontal plane like our tractor. If we start having a vertical plane, we could have simple up and down motion. So I could get a ball and drop a ball. That would just be going along the Y direction, right? So that's 1D motion in the vertical plane. Or I could be throwing it at an angle, and that is 2D motion in a vertical plane, okay? Just like we have here, okay? Alright, so that's it for this video. Hopefully you got a better understanding now of what different planes are when we talk about a horizontal plane, a vertical plane, that we can have simple motion, 1D motion, like going backwards and forwards on a horizontal plane or up and down on a vertical plane. And then when we have angles, and if we have angles, that's when we start using our different ways of measuring the angle, where we have true bearings or whether we have quadrant bearings. So whenever you talk about displacement or velocity, of course you need to say the magnitude plus the direction, and you can choose to use true bearings or quadrant bearings, and sometimes when you read a question it will use one of those as well. So hopefully that makes sense to you. Now of course if you're in my class, you're going to be coming to class and you're going to be doing these things. We're going to have different cards here that's going to test your understanding